Thank you guys for joining. It's definitely a conversation I very much look forward to. A conversation about at least what I believe to be one of the most interesting, stimulating, and challenging parts of crypto, MEV. But even more excited about it because we will talk about the role of privacy in MEV. And certainly privacy, I think, will play a critical role in ensuring and protecting the key design principle of blockchains, which is decentralization. But before we get there, let's do a quick round of introductions. I will start quickly on my end. I'm Lucas. I'm heading up the ecosystem at Nillion. Nillion essentially is a public decentralized network for private storage and private computation, essentially utilizing different privacy-enhancing technologies and democratizing access to those technologies. And as on the ecosystem front, what I do essentially is to talk to projects. I source them, curate them, and help them in building out the products, which is pretty exciting to see a vast range of projects that are excited about introducing privacy to the tech stack. We have seen lots of different verticals from finance, supply chain, healthcare, and I'm basically working with those projects to identify synergies and get those projects built. In terms of overall, I've been part of the team since the beginning. Since 21, I've worked on different things very closely with Tristan, who is also part of the call today, initially on crypto economic stuff, on governance stuff, but over the last year, sort of looked primarily into product and now heading up the ecosystem. So that's it briefly about myself. Jonathan, do you want to go next?
So I'm Jonathan. I work for Flashbots, so in the Ethereum space. I'm on the research team. I work exclusively on privacy enhancing technologies and their application to blockchain, in particular to how they can help mitigate or enhance, in some cases, the MEV action space, as we are, working on in Flashbots. And prior to that, I'd been working on privacy preserving machine learning. So that's my background as well. But yeah, in a way, think about it as like, private and secure computations for various kind of applications.
Awesome. Tristan next?
Sure. Yeah. Hey, I'm Tristan. I head up a lot of the crypto stuff at Nillion, so kind of the resident on-chain person. But anything from, token economics and governance stuff back in the day, these days more focused on a little bit more on the tech side, on building out some more coordination layer stuff, but anything product marketing, all of it. If it's crypto, I'm there.
Andre?
Hey, I'm Andre Lapitz. So currently, I've been advising Nillion for about 2 years now. I've also, with Shireen, who's here today as well, founded Choose K, which is part of the Nillion Founding Entrepreneurs Program and is an entity that's kind of building on our team's experience with MPC over the past 10 years at this point. We started back at Boston University with the wage equity study. We did another MPC startup after that, Nth Party, that was acquired by a public company in the ad tech space. And now we're trying to address the kinds of problems we're going to talk about today using the experience that we've gained building and deploying MPC solutions over the past 10 years.
Cool. Well, guys, thank you very much for the intros. I think before we jump into conversation,
what about Shireen?
No.
Okay, yeah. I thought. Okay, sorry, Shireen. Yeah.
Sorry, I didn't. Sorry for the lack of coordination. Yeah, certainly Shireen has a much richer background than what I talked about, so we should include that as well.
Of course, sorry for that. Shireen, go ahead.
Great. So Shireen Shermack, founder also of Choose K, along with Andre, and we share a history of creating privacy-preserving workflows, and at first in ad tech and now in financial services. My financial services roots go deep. I've been in traditional banking, but also left in the early 2000s to work in fintech startups. And I've been the CEO of a couple of successful ones. And since then, have helped entrepreneurs who are PhDs take their IP out of universities. So when I met Andre and Frederick at BU, it made total sense for us to spin out a company together. In between that and this one, I also helped a bunch of MIT PhDs spin a quantum computing company out of Will Oliver's lab, and then came back around to work in cryptography again now, and pointing it more towards financial services and fintech. So we're very interested in both Web 2 and Web 3 applications, and we feel like both sides can learn a lot from the other, for sure.
Awesome. Well, thanks, Shireen, for that intro. Great stuff. Before we jump into the conversation, I think it might be useful to provide a very brief background about why we talk about what we talk about today, to set the scene a little bit and provide some context. And I think that the best way to do that is really to look at blockchains at its most basic form of what they're trying to achieve, right? So blockchains are coordination systems, and they have coordination systems to eliminate trust, right? Trust which we need to have in centralized parties, trust which we need to have in a few single parties, specifically for agreeing on the order of the state of the blockchain. And I think we kind of got there until we, or better said, until Phil and his friends published Flashbots 2.0 back in 2019. Obviously, Jonathan, you will probably know him quite well. That really, I think, raised awareness in the scene, in the community, how centralized certain powers still were at this point and still are in the space with respect to some parties having more power than others, right? In terms of inserting their transactions, censoring, reordering. That is something I don't think we're quite aware before that paper, as clearly at least. And that is a threat, right? Because that information asymmetry that exists and still exists certainly is a threat to arguably the core principle of what we're trying to build here, which is decentralization, because those are centralizing forces that pull us away from what we're trying to build here. Now, then we have seen very exciting development on obviously the Flashbot side. You guys were incredibly active and successful in helping us to regain certain parts of decentralization that might not have been as strongly existent at that point, with MEV Geth, MEV Boost, MEV Boost specifically introducing proposability separation, enabling a much wider range of validators to join, thus decentralizing the validator set, whilst specializing the builder sets away from sort of the validators. But what we still see today are certain centralization forces, right? We have builders and searchers where we have only a couple of them that are building the vast majority of the blocks, and we need to find a way to also ensure that we can establish and guarantee decentralization in those parts of the stack to really build those trustless systems, which we have started to build back in 2015, 16, or arguably Bitcoin 2009. Now, to get there, I think privacy will play a critical role, right? And that is also the reason why we have this conversation today. But before we get into specifically the role of privacy, I would love to look into MEV overall and sort of ask on a high level to everybody of us what we think the different forms of MEV are, if there are differences between them. Some might be more toxic than others in the context specifically of centralization forces, but also maybe more broadly from a user experience perspective. Maybe starting with you, Jonathan, are there any specific forms of MEV that you find are more toxic and less toxic forms of MEV? So if
I think the established consensus is that if at the end of the day the retail users get a worst execution, you can say it's negative, right? And then the question is like, how do you define these retail users or the end user of the application? For example, most people would agree that front running and sandwiching, for example. So I don't know if we need to do an introduction on what that means, but that would be fairly universally considered as like negative MEV. Was like arbitrage and liquidations do provide a service to the overall network, and thus can be considered relatively like positive MEV. Now the thing is that if a searcher that finds like an MEV opportunity makes money out of it, and we know that the user doesn't lose money, it means that this money has to come from somewhere. So someone is worse off at the end of the day. And in this case, it could be the liquidity providers in Uniswap pools, for example. So some users still pay the price of MEV, and in a way it's about deciding who has to pay this burden in that case. And I think that the current state is that we kind of like agree that for now it's better to make sure that users don't pay it, and then we'll have to design better applications to make sure that it's reduced overall in a way, and that liquidity providers are not being hurt in the long term either.
That's actually interesting. I hadn't thought of it that way. Is there an analog in traditional markets for liquidity providers paying the price of kind of arbitrage being how is it viewed in traditional markets?
I guess I would say that's what hedge funds are around to sort of mop up, but they're heavily regulated. So while they've made the markets like incrementally over time more efficient, they've been so heavily regulated that a lot of the gain has been worked out of the system and actually goes back to the regular participants. So it's tough to imagine that analogy kind of moving over into the Web3 space, because regulation is what kind of keeps it fair.
There's definitely mappings also to, depending on where you're talking, but like especially that LVR, SexDex ARB stuff that he's referring to. I think when it comes to the on-chain side of it, there's a lot of what people are trying to build now to be aware of that is frequent batch auctions or things in this space that were looked at for the same kinds of problems in the TradFi space, like a couple decades ago. And also I think related a lot of these conversations around payment for order flow, right? That was just like a big mainstream this is MEV moment, I think, for non-crypto people. Cool.
I mean, building on what you said, Jonathan, in terms of sandwiching, front running, essentially what you said, the user having to pay a tax without necessarily knowing to pay a tax, right? If we zoom into that specific part of toxic MEV, and we agree that maybe regulation isn't the right way of dealing with it, and we want to find a cryptographic or technology-based approach to find solutions, then do we think collectively that there is a way to get there without privacy? Is privacy absolutely essential to get there, or are there other approaches to eliminate toxic MEV without necessarily relying on regulation and centralizing mechanism?
Okay, that's good that you brought up like the latter point, because otherwise I would have had like an easy escape out of it. Because if you think about it, the initial Flashbots product do without privacy. If we define privacy by like cryptography technologies like enabling privacy, that we do because we're based on a social contract between like users trusting us and block builders and the other actors trusting us as well. But at the end of the day, I think what you want if you want like formal guarantees about MEV, what you want to provide the users with is pre-trade privacy, right? If no one can see your trade before it's actually locked on chain or committed to be locked in a future block, then you should be able to prevent some like the harmful form of MEV extraction. And that's probably like a simplification. Don't fully quote me on that, but I think that's a fairly decent mental model to think about it. The issue with that is, again, how do you define privacy? And I think that's one of the things you wanted to mention as well. But we've seen like a rise of encrypted mempools, for example, right? So is it enough to like have transactions being encrypted before they are actually like taken by a committee of block builders or whatever actors you call in this kind of like systems that would then add them into a block, commit to the block, and then only then the block would be decrypted, right? To me, what it looks like is that you're actually just pushing the MEV to another side of the system, right? Because if we're looking at how these encrypted mempools are designed, in most cases, they relied on threshold decryption, right? So you need like, I mean, I'm not going to teach you guys anything about it, like if from the MPC side of it, but you rely on a set of validators to reconstruct like a private key to perform the decryption, right? But it means that at some point, one of these validators is going to provide the share that unlocks the decryption, right? And this actor has an edge over everyone else in the system. And of course, it's not just a single one. It's like anyone who is in the position with having to put like the final share to perform the decryption technically has an edge and could exploit that edge to extract MEV in the next block or to sell this decryption share in one way or another. So it's appealing to encrypt everything, but if you start zooming in, you quickly realize that you're actually just like pushing things.
We definitely want to touch on this because I think this is something that, and very impressive the work that has been done already, looking at all the dimensions of the different protocols and how you can compose them to solve like the different parts. But this is something we talk about all the time, and we've been talking about it for the 10 years that we've been doing MPC, because we kind of entered the space not as MPC researchers, but as as opportunists to see if we can deploy something that solved a problem back in the day. And one of the things that we still talk about at the MPC Alliance, which is a consortium of about 50 to 60 MPC companies, is that the ultimate API for protocols, for MPC protocols, or even FHE and TFHE protocols, hasn't really been determined yet. And we often, jump ahead of ourselves and think, oh, we know how to build database engines, or we know how to build compilers, therefore we can build an MPC compiler right now. Compilers and operating systems and database engines, they evolved over decades based on business use cases that fed back into the organizations that worked on these things and the teams that worked on these things. So in the same sense, actually just to kind of zoom in on that last comment, which I think is very interesting. The issue that you bring up is actually a symptom of the particular way in which MPC or FHE might be used in that workflow. There is a way to push that back to the sort of the preparation stage of the data rather than the decryption stage. For example, you could distribute correlated randomness among the contributors to the computation in advance, so that in fact you can't even compute the result unless all of the participants actually contribute something, right? But of course, then you have a different set of SLAs among the contributors to the input that needs to be maintained. But the question that we have to kind of solve on the MPC vendor side is, how do we allow users such as yourself to actually explore that space better? Because right now, I mean, you very reasonably choose MP speeds, for example. It's mature, it's adopted by major players like Carbine Stack at Bosch. It's actually apparently, I don't know how much I can talk about it, but the adoption for that is actually going to be growing in the near future across other organizations. But at the same time, MP Speeds has a very specific interface that it exports. And there's definitely, and certainly at Choose K, what we're interested in is kind of going beyond existing techniques, given our background in MPC, and seeing, are there other ways we can deliver this that could be compatible with different SLAs and explore what's possible. So that's certainly something that we're interested in doing, and why we kind of started Choose K.
Jonathan, I had a quick thought while you were talking. Just, you're talking about how it just pushes things down the way. And I'm curious how you, in your research or, in your work, how do you model what's going to happen next? Like, do you do some sort of system dynamics modeling to understand what the implications might be? And then do you track those things when you do a release?
That's a good question. I don't think we do directly at Flashbots. I think there are some initiatives at the Ethereum Foundation to provide models, actually, which is, I think, extremely important to study this kind of dynamics, as you mentioned. It's a whole different job, of course, to come up with a correct simulation model and making sure that it does what you intend and like speaks the truth, but it's very interesting. In a way, I would say we reason from a probably not like I want to say simplified, but I don't think it's simplified because it probably works in all cases. Think about how most AMMs work on Ethereum, right? Any change that you make to an AMM has to go through a transaction, right? So what the kind of guarantees that you have, you've got two pretty much. You know that the state of the reserves of a given AMM, like Uniswap, for example, is not going to change between transactions, right? That's why most searchers, what they end up doing is like paying to be backrunning a user transaction. Because if you follow a transaction that changes the state of the AMM, it's one of the only way to be 100% certain that your view of the world is correct. Nothing is going to change between these two transactions, right? And the other is to try to bid, and that's another of the auctions that happens on Ethereum, for the top of the next block, because you know that in between two blocks, no change is going to happen, right? So that's a very simple model of like how things work, but that gives you two absolute certainties on what happens on chain and allows you to trade. And that's the interesting part, because like if you look, there's like very interesting papers that came up like not so long ago on quantifying MEV extraction and the type of strategies. Where do they happen? Are they exclusively on chain? Are we talking about centralized exchange versus decentralized exchange? And what happens is that MEV extracted solely on decentralized exchanges, you can think of it as a solved problem, right? It's so efficient that searchers compete so hard in this thing that they have to pay everything they're extracting to validators to get that transaction included, because there is so much certainty on what's going on. The game is now played at extracting MEV between that arise from discrepancies between centralized and decentralized exchanges. Because on centralized exchanges, you've got this uncertainty of the price changing way more frequently than it does on chain. So it can create this imbalance. And of course, with imbalance comes risk, and with risk comes the need for capital if you want to extract these opportunities. So it's a different game that is, starting to, or I don't know if it's starting, but like being played at the moment.
Well, also maybe right now, I think the numbers that I've seen are that this is still relatively uncommon, but if Suave comes out, all these intent systems come out, some form of chain abstraction, whatever, cross-domain MEV, I think will bring the complexity back to the chain side as well.
Building on the discussion point that Andre, you started, and obviously Jonathan, you built on in terms of the experiments that you've done, I would love to touch on that a little bit. So maybe for those who are listening who might not have had a chance to read the reports, the articles that you've published, what you guys have been working on Flashbots is essentially trying to utilize different privacy enhancing technologies, right, for different parts of the MEV stack. And one of the things you've been working on, obviously, is the knapsack issue, the knapsack problem, where you were trying to, correct me if I'm wrong here, but where, if I remember correctly, you were essentially trying to create a block, right, where multiple sort of searchers were submitting their private bundles, and you were trying to maximize the value you could extract from those bundles by creating essentially a block. Next to that, you have also done research on basically the backrunning transaction, where I think a user submitted a private transaction, and then a searcher essentially was generating a backrunning transaction to exploit what we just talked about, the sex-dex arbitrage, which exists, right? Now, doing that research and experimenting with utilizing MPC specifically for those things, what were your experiences? What were the great things you discovered, and maybe the challenges that prevented that from being adopted in the short term on the Flashbot side?
That's a very, very interesting question. I think that's echoes perfectly with what Andre was saying on what's the right SLA and what the MPC providers how they should interface with MPC consumers that could be Flashbots, for example. The TLDR is that if you think about what we would like to do in an ideal world, MEV extraction from if you put yourself in the shoes of a searcher, and what we're trying to do now is to in a way make their life harder by introducing confidentiality in the computation, right? But if you want to still enable MEV extraction, because we've talked about it before, trying to prevent it would just push it around the corner. So you still want to enable it. It means you want to enable searchers to simulate a transaction. So basically to take a user transaction that is potentially encrypted, secret shared, protected the way you want, and still compute its impact on the future block, right? That's what we're trying to do. And what that means in the North Star version of what that means is that you need an Ethereum virtual machine that can act on fully encrypted data. So you need like an encrypted EVM, right? That would be like the ideal interface for people like us, for example. Turns out that, you know, I'm not going to breaking news, it's complicated, right? You're not going to get like a fully encrypted EVM in pure software cryptography tomorrow. So we're taking two approaches. One is, you know, you could say that is Suave, and that's why we're building Suave on trusted execution environments, for example, because that's a very pragmatic choice that allows us to get very close to embedding like providing like an encrypted EVM to users. So that's one way of doing it. The other way of doing it, and that's the line of work that you were evoking before, is to say, okay, we can't really do full EVM. So how about we try to carve out portions of the protocol, portion of the actions that searchers would do, and try to replicate like this small fraction of the actions in the encrypted realm. So that's the line of work with the private background, for example, or the knapsack. And I can touch on both. So the knapsack option was to try to say, what is the closest problem that we can think of in computer science literature that looks like bug building? And in the first instance of the project, it looked like knapsack was a good choice for that. So we worked with a team called Hashcloak to they pretty much like led the work, and we helped them with that to build an MPC knapsack solver, basically. It turns out that knapsack is not really a good approximation for block building, for the simple reason that knapsack works if you have blocks that do not conflict. And by blocks that conflicts, or bundles that conflicts, let's say, what I mean is that if you have two transactions in the block that would change the same state or the state of like the same contract, then potentially they would be conflicting, because like you can't, the way you order them would change the outcome of the computation. And in that case, knapsack is not good. So if you had like the guarantee that none of the transactions you're dealing with would be conflicting, yes, you can probably use like a knapsack solver to build blocks. If you don't, you probably can't. That's the bottom line.
Out of curiosity there, did you find a better kind of simple mapping for the reality of what block building looks like from the computer science literature, or kind of are you starting to have to model something a little bit closer to the reality?
In a way, yes. My colleague Robert Hennessy, who wrote like the initial article on MPC, would have way more than I do to say about it. So I don't want to rag him on that. But I would say I think it's now like common knowledge that block building and transaction conflicts is not too dissimilar to database conflicts as well. So if you can map the state of like all existing transactions, you can probably like try and like resolve conflicts first to, in a way, make your life easier and like separate what is conflicting versus like what is not conflicting, and that creates like two separate problem spaces for which you can have like different heuristics to solve the block building at the end of the day.
Interesting. And then the back-running transactions one, if you want, you can go over it a bit, but I have a specific question to it, which is something we looked at back when it got released.
Okay.
We were interested in this direction of research, and we were like, is this a thing we should be kind of focusing our attention on? And then we thought about it, and we're like, realistically, are we going to get to production with this use case in the near term? And maybe not that fast.
Probably not.
But one thing that was an interesting kind of takeaway was the searcher language.
Yeah.
And you define a searcher language in there of kind of how searchers can define what they would want to do, their logic. In retrospect, is that searcher language still kind of expressive enough for how you think about things?
Probably not. The searcher language was a way to make the demo like more compelling, to show that, not only you could do confidential backfriending using MPC, but you didn't have to trade usability for that. Like you could still allow searchers to program the strategies, because that would be, if tomorrow you sit at a table with a searcher, one of the criteria that's going to come up is like, what can I do with the tech, right? Can I steal inject my my alpha on what I know from transactions, for example. So that would be one expectation. I think, you know, there's probably like different ways of doing that. The language is one. Same thing, I think Andre before touched about compilers. That's probably like an even more appealing way. You know, you can be on the camp of like you like DSLs or you don't like DSLs, but probably like, yeah, exploring compilers would be a better way to provide these kind of interactions, I think.
I think one of the challenges that will continue to exist, and this is again, I mean, the rationale for Choose K and its business model and reason to exist is we still strongly believe that it's too early to imagine that domain experts who are not working with MPC or FHE experts, or even domain experts who are not themselves experts with MPC as well, are realistically we're not going to be able to offer them tools that they can use by themselves to build the kinds of applications that they want to build. We did a similar exercise to the back running, and we're working on actually sort of adapting and just to kind of understand ourselves, the back running example that was implemented as well. But we did an order book example in a similar vein, and it's completely agnostic and independent of the underlying secure computation protocol. All we did was we wrote an order book, and this is actually open source. It's on the Choose K GitHub, an order book protocol that just pulls out the base operations, and it actually pulls them out in multiple tiers. So you have the lowest tier, which is things like comparisons and integer operations. And basically it says, here's, you know, these are black box. We don't care how you implement these. Everything is built on top of that. We also call out the middle layers as well, because more complex operations, there are MPC protocols for more complex operations that can be applied holistically to a collection of inputs, for example. Like, you know, you can sort two values, which is not the same as comparison, or something like a max operator. There may be a different protocol for something like that. Ultimately, the entire order book implementation as well is not something anyone would write if they were writing an in the clear order book or an order book algorithm that they hope to run in a TEE. It's a completely different set of data structures and short, but algorithms. And realistically, that's just the way it's going to be for the next several years, at least, probably, you know, up to the next 10 years. So it's definitely the case that while languages, like our own opinion is like, while languages are a way to start to, you know, build these kinds of build the things that we can ask SLA questions about, like what kind of SLAs are the different parties involved going to have to sort of conform to if they use this particular language that has these set of particular protocols. It's not going to be something that is a ready to go kind of toolbox that anyone can just come in and use.
Well, they can, but the performance won't be maybe production ready.
I would argue even more so. Not only will the performance not be production ready, going back to the SLA's question, and again this point, right? It's very easy to miss that last point that was brought up about the last party having all the cards at the end, right? That is not something that you will notice immediately, or maybe even notice at all in a particular implementation. It's something that only happens when you actually sit down, get pretty far and deep into everything with everybody who's aware of all the different dimensions. And then you discover, oh, wow, like all the academic papers just completely skip this part. Like they don't worry about this stuff. So I would argue that it's not even just about the performance. It's about just the data model, the incentives of the parties involved. I mean, we have a very similar example in advertising technology for this, where you can do off-the-shelf private set intersection to determine who sees what ads. But ultimately, the website operator who displays those ads can just look at their own website and see what ads are being displayed. And you can invest all the time in the world in doing a perfectly implemented and efficient private set intersection. But at the end of the day, it doesn't matter. And you probably should have done something else because you're paying a cost for something that wasn't necessary given the realities of what happens after the output is revealed. So yeah, so there's definitely a lot more work that needs to be done to address some of these things through collaboration between domain experts and MPC, FHE, et cetera, experts.
Awesome. Zooming out from that a little bit and looking back into the SWAF stack and the different privacy enhancing technologies that you guys are looking at, I'm very curious, Jonathan, to learn more about your sort of decision-making process in selecting different privacy enhancing technologies. Now, obviously, in the short term, my perception is looking at what you guys have been working on over the last couple of months quite closely. You've experimented with different privacy enhancing technologies, right? You've experimented with MPC, obviously you yourself. There have been FHE attempts. The CK, there is obviously threshold encryption, there are TEs. In the short term, you sort of settled on trusted execution environments being just the most performant solution right now. But what is the sort of consideration set that you guys are looking at from a perspective of scalability, latency, trust assumptions you need to make in picking those? And how will that change in the medium term? So in the short term, obviously, trusted execution minds seem to be the stack you guys are going for. But is there an intent to move away from that in the medium term? And if so, on what basis, on what decision-making basis, essentially?
Right. So it's, in a way, it's a complex answer, because I think the root of the problem here is that we tend to equate trusted execution environments with Intel SGX, right? Which is true as of today, right? SGX is probably like the most widespread and easy to use and commercially available implementation of a TE. Is it like the final form of TEs? Probably not, right? Because most of the problems and attacks coming from, in many cases, like the academic literature that were flagged against SGX come from its design. And that's something that we tend to miss when we are we're quite sometimes early to dismiss SGX as like a completely broken tech. It's not that simple, to be fair, and it's mostly based on how it's been designed, and especially how it's been designed to be cooperating with the Intel architecture, to be sharing architecture and microarchitecture with Intel CPUs. So the conclusion to that is that for now, if we want to ship something, it still makes sense to build on SGX and probably as well to build on like other commercially available TEs like SCD or TDX, all these kind of things, right? How is it going to look like tomorrow, right? On the research team, we have like different perspectives. One is to keep on exploring software cryptography. So all types of MPC, as you can imagine, like, and I'll put like FHE under the MPC umbrella in the sense that, it's just a way to trade communication for computation. But at the end of the day, you're still doing an MPC. And the other is to try and think about, can we find a different TE, one that doesn't have the same design flows than SGX has, right? And there's been some proposals in this direction. Like if you look in the literature, for example, there's a project called Keystone that is trying to build a TE on RISC-V architectures, right? I don't follow like the project very closely, so I don't know how ready it is, if it's just going to be like an academic experiment, or if there's ever going to be a RISC-V design based on Keystone that you can buy. But if so, that would probably make sense to look into it. Even closer to hosts, there's as far as I understand, the way Nitro enclaves on AWS are designed is fundamentally different from how SGX works. Doesn't have like the same collocation design flows than SGX could have. So it could be interesting to look into that as well, but still, would not remove the one vendor root of trust problem that is always going to be there in TE. So another question is like, and that starts to become very interesting, especially for you guys. Can we rely on more than one vendor, right? So, and what I mean by that is, what is the interplay between TEs and MPC? What kind of protocols can you come up with to, in a way, both accelerate MPCs and strengthen TEs by, collaborating and building protocols that rely on both? I think that's a very interesting line of work to to explore, for example.
Yeah, that's actually something that hasn't been done, which is that we know that there's a trade-off in MPC. It's actually related to the origins of the Nillion protocol, NMC, that was published last fall, where there's a family of MPC protocols. If you can have enough correlated randomness and you're willing to do a heavy enough computation locally, you can actually avoid communication. And that is something that you bring up a good point that is definitely something we should on our side look into, which is if you're willing to, if you're able to use the speed up that TEEs offer to just do a much more expensive local MPC computation, and therefore get rid of the communication between those two TEEs so that they don't have to communicate, but you are doing MPC now across both of them. That's a really interesting question. And it's something we should look into. And as I'm aware, I'm not aware of any publications that explored taking advantage of that speed up that the TEE gives you to do something much more expensive locally as part of a two-party MPC, for example. I had a question kind of, is there anything that, are you seeing anything at all when you look around in the sort of traditional finance space, or are you just not even following what they're doing with respect to privacy enhancing technologies? Because one of the things we looked at was JP Morgan did a private order book. So I guess kind of, I wonder, is there anything in that space that you're looking at, makes you feel more confident, or do you feel like you're far ahead actually of that space on the Web3 side?
You front-ran me on that one because that was the only example I had, I think, or one of the only examples.
Oh, you should have encrypted so that I wasn't able to front run you. But...
Being attacked.
I saw your face change when he mentioned that one, and we've been looking at that quite a bit, and it hasn't, we haven't seen follow-ups. We haven't seen anything to follow on to those projects, but it was very interesting to us because we saw it just as we were deciding to point towards financial services. And if JP Morgan did it, it would be fantastic for us and fantastic generally because they're seen as a leader in traditional. So, yeah.
My interpretation of that is that the reason why we're not seeing so many things is that it's probably still in a very early experimental phase, and probably not widely publicized because, they're probably still prototyping things. Because I know, for example, that most of the industrial actors in the FHE space, for example, they do communicate with TradFi, and they probably have some prototypes in TradFi. Is it adopted in production? Maybe not, right? But I think the appeal is there, and the question is always the same. It's like we were talking about incentives before. What are the incentives for TradFi to adopt these technologies, right? They're not going to adopt these technologies for the sake of privacy. Just like in social networks and communications and things, we've seen that users won't just adopt privacy for the sake of privacy, right? That would be great, but that's not how it works. So the question is what new use cases does that unlock for them that they could not do otherwise? And that's really what we have to think about, both in, I guess, in TradFi and also in the Web3 space.
Yeah. I mean, I think that
Go ahead.
I was gonna say that I think that it makes sense to me. Of course, it does. This is the bias that I have, and I'm bullish on. But it makes sense to me that a lot of this innovation can and should come from crypto, from Web3 stuff, because there's a lot more incentive to it's built into the core ethos of it in a way that tends to maybe only come from regulation or very specific niche applications where maybe you can get users to care enough or whatever it is in the traditional markets. But who knows?
Yeah, I mean, I was just going to say for investment banks and broker-dealers, the incentive is always, how can I get more order flow? How can I get more customers? And I would think for JP Morgan, it's just, how do I get my customers to disclose more of their trading strategy so that I can internalize the order flow? And that can't happen unless they can say, I can't see your strategy. And so there are some really good incentives out there, and I can completely see why they did that. I can also completely see why they might not pursue it. I mean, maybe their risk team killed it. Maybe, we're just hypothesizing. We have no special knowledge, but yeah, it seems like it would be too useful to not continue to explore. And, for now, I feel like it's just too limited. Like just using blockchains to lower the cost of doing accounting is not going to be the end of it. And it's really great from our perspective that Web3 is going to lead the way in showing that some of this could work.
I mean, one of the best parts of this space is that, especially in recent years, it's like put a jetpack onto research cryptography and turned it into applied cryptography very fast, sometimes too fast even.
Yeah, I mean, one thing that's different about Web3 is, the challenges faced by MPC teams in Web2 firms, I always say, are the same as the challenges faced by MPC teams in the wild who are on their own, which is, even if you're inside a large firm, such as the team that I'm speculating, but I think that their situation is probably similar. That team is advocating for MPC, but they are trying to find product market fit, trying to find a budget, trying to convince someone that this is actually worth looking at. And realistically also, I mean, we see this in advertising, and I'm sure it's happening in fintech as well. Sometimes the legal teams basically look at it and say, well, it doesn't matter that it's encrypted because the consequences of what you're doing are still the same. And so, well, we already have a way to deal with on the input side, we already have contracting and we already have risk mitigation, we already have insurance. So what are you really adding to this? Sounds like you're just making things more complicated. So to that point, yeah, there's a really good point that what are the new business use cases that are enabled by this is the product market fit question. I mean, I actually have a question, like, is that something that in Web3 is much more clear to see, like because again, Web3 currently, a lot of things work, right? It's good enough. Things are out there. Like, what's the...
I don't know about good enough.
Yeah, well, that's the question, right? I mean, how are the dynamics? And because I'm just to be, I guess I should have said this at the beginning of the call, like on the Choose K side, we come from more kind of a traditional background and not so heavy in Web3. Like, what's different about the Web3 dynamics that might lead to faster adoption or might lead to fewer barriers for teams who are trying to promote these technologies?
I think there's two sides to that. Like, one is that people expect innovation in Web3, so you'll be encouraged, like, both by the community and even by investors to come up with like very ambitious technical solutions. But to go back to Tristan's point, it doesn't mean that you'll get like real adoption, right? If tomorrow we as Flashbots, put out like a product for an encrypted mempool, even if it's programmable, whatever, but is like several orders of magnitude slower than what you could do with plain text transactions, it's not going to be adopted, right? Because at the end of the day, it's still a latency game that can cost money to the players playing it. So there is still at some
would it
point...
be adopted even if it was the same performance is my question always, because after having spent so many years with MPC, and Shireen can certainly also attest to this, the amount of hand holding that you have to do, and the amount of institutional obstacles and other things. I mean, here they're not institutional, I guess they're community obstacles. But I'm curious to, like, can you extrapolate on that specific scenario? But let's say the performance was actually almost the same. Like, what would be the barriers left to overcome? Because I think that is something we should prepare for, even as we work on the technical barriers.
UX, 100%. That's I guess that captures like what you were describing. It's like, how do you make it like simple enough for users to adopt it, right? Because at the end of the day, what you can do with that, the incentives would be, I'm going to make the users order flow available to like more and more actors. And that's what Shireen was describing as well. That's the main incentive for like these big players. But users surely should be compensated for these kind of things. So if you can make it like very straightforward for any transaction that goes into this system to be protected from a pre-trade perspective, made available from a programmable perspective to these actors, and at the same time guarantee some rebate to the users in proportion to like the contribution of that transaction, then you've probably got like a very strong product market fit at the end of the day.
Yeah, it definitely aligns with our experience. I mean, I made a I made a part of my academic career on usability of MPC, so it's definitely a question that can be studied even today. So that's really great to hear. I mean, I think that this question is something that we can start working on even today, right? We don't have to solve the technical issues. We find the low-hanging fruit that are possible to do on the technical side already, and then we can start learning about the usability and UI UX kind of aspects of it already. And I think, you know, that's certainly something that our own personal experience, Shireen and mine, reflect.
I would
And
just say,
T's are great for that as well.
yeah, I mean,
It's a great way to experiment. So
we would be exhausted of pitching if all we did was try to tell people that things would be better and more private. It has to have a better workflow. It has to enable a workflow that people would prefer. That's it. And a lot of the times when we're working with customers or working with, to try and get betas up, we'll build the UI and the UX, design the UX, because the cryptography is not going to get done if we don't figure it out end to end. And if you want to get it done, we've just found, don't make it somebody else's job. If you keep it your own job and just make sure it gets out there, that's important, because it's the very, very early days of the technology. So you've kind of got to be willing to suck it up and, do whatever it takes to get the implementations done, and not worry too much that you're building a UX which requires no cryptography skills or limited. Just do it and get the use cases out there, because every use case that's out there just seems to change the way people think about things so much.
well, I think a good way to think about it from the customer standpoint, so be it in TradFi or DeFi, if we assume that what they want at the end of the day is to make the most out of the order flow they have access to, then the problem you're trying to solve is to show them with tangible metrics that by putting together their order flow with the other actors that they perceive as their competition, they will make more money than by mining their own order flow and nothing else. If you can do that, then you've solved your adoption problem as well, most likely.
That goes for a lot of crypto composability in general, like as a thesis, not just order flow. I think that there's a lot of people there's a lot of industries that could do better if they cooperated on terms that they could agree on, but just don't.
Is there some way that people have thought about to attribute slippage reduction so that so that the customers do get the benefits?
In DeFi or in TradFi?
Oh, in DeFi.
In DeFi it happens. Yeah, we have a project called MEV Share. If you our entry point from a UX point of view is called Flashbots Protect. And it's very simple. It's not, well, let's say it's not more complex than using MetaMask. So if you're already a user that is onboarded in crypto and you can use MetaMask to send transactions, then you can use Protect. And it sends your transactions directly to this system that we call MEV Share, which is a matchmaking system that allows searchers to bid on your transactions and to promise you a rebate in return for your order flow. So it's an order flow auction. And there's another one that is not from Flashbots, but that's called MEV Blocker. And I believe they also offer some rebates to users sharing transactions for that. So it's the whole space of order flow auctions that is kicking off in the Web3 space.
That's a low-hanging opportunity for testing out MPC and FHE. And exactly the kinds of things that MPC has actually been adopted for, benchmarking, this kind of low stakes kind of thing. And that's where you can start learning about things like usability of MPC and so on while you work on the hard stuff. So yeah, it's definitely something to look into and a great idea for everyone on this call.
Let's do it.
Great. Well, guys, I'm conscious of time. One last question I have specifically to you, Jonathan, is what are you working on right now? What is happening in Softland? What's the next step for you guys?
There's quite a few things happening. So of course, the Suave testnet is available now, so you can start, playing with it. See, the doc is available. We just out of the East London hackathon, and there's been a few submissions in this direction. So it seems that is going in the right direction. In terms of research, there's quite a few things. now with that, we are committed to the T/SGX line. Of course, one obvious research direction is how to strengthen SGX. You know, everyone is aware by now of like the shortcomings of SGX, and for those familiar with that, there's this problem of like side channels that can, you know, both arise from the way SGX works, but also from the way you program it. So one of the things we're looking into is how to basically mitigate the side channels that would come from the way you interact with SGX itself. Another direction.
Guy with
Sorry?
block security, right? I feel like that's what the T people talk about a lot.
Another direction is, of course, to keep on building on the MPC background. So, you know, utilizing different protocols. Of course, like, you know, MP speeds is great, but it's definitely just like a research framework, like to build prototypes. I'm, you know, pretty excited myself to look into how we can do that in FHE as well. And we're also looking into, you know, other kinds of like privacy definitions, let's say, because like for now we've mostly talked about protecting the privacy of the inputs. I think it's like pretty important to understand the impact of like what we release afterwards, so the output privacy. That's something that could be, especially when you start sharing all the flow. What can I learn from these things that I've, you know, if as a user I decide to expose or to publicize part of my transactions in exchange for a kickback, what am I really signing up for, right? Do I really know that, or am I at a risk to be front run by another actor somehow?
Cool. Well, guys, I think time is up, but it was a pleasure. I think I'll definitely learn a lot. I think we covered a lot of ground. And it's very exciting to see what you guys are building. It's very exciting to see that you guys keep experimenting with different private enhancing technologies. Obviously, on our end, we will do everything we can to make sure that cryptographic-based solutions like MPC and others keep progressing, that performance improves, such that fundamentally we can find more trustless or more trust-minimized decentralized solutions that are not necessarily subject to single points of failures or hardware-based solutions. But it very much makes sense that the path you guys are going after right now, and I'm very excited to keep reading research papers you guys are publishing. At the same time, I think there are future grounds for collaboration, specifically when it comes to privacy enhancing technology experiments and what we're building here. So thanks, Jonathan, for your time. Thanks, Tristan, as well, and Andre for your time. It was a pleasure.